Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Adib bin Abdurrahman. I'm from Group 5 and I will present about Modular Electric Drive System. Now, I will start with the introduction. Modular Electric Drive System is also known as electric vehicle. Electric vehicles are either partially or fully powered by electric power. Electric vehicle also has a low running cost as they have fewer moving parts for maintaining and also very environmentally friendly as they use less amount of petrol or diesel. There are four basic types of electric vehicle available in market nowadays. The first one is hybrid electric vehicle (HEV). This type of electric vehicle is powered by both gasoline and electricity. There are many hybrid electric vehicles in Malaysia such as Honda Civic Hybrid and Camry Hybrid. The next one is plug-in hybrid electric vehicle (PHEV). This type of electric vehicle has the capability to recharge the battery through external sources. Next, battery electric vehicle (BEV). This type of electric vehicle is fully electric cars with a rechargeable batteries and no internal combustion engine. Lastly, the fuel cell electric vehicle. This fuel cell electric vehicle has a clean and efficient power plant that make electricity. Only a little noise is produced by the electric motor. For our case, we are choosing Ferrari SF90 Stradale as our research. This car is the first plug-in hybrid powertrain produced by Ferrari. The battery can be topped up on the road via the engine or from the energy recovery. It uses regenerative braking system to charge the battery. Whenever the driver hits the brake, an electric motor generator is sandwiched between the engine and the new speed dual clutch transmission. It can help to slow the car and generate electricity.
Assalamualaikum and good afternoon. My name is Nur Natasha Atikah binti Rosli, and today I will explain about the methodology of modular electric drive system for Ferrari SF90 Stradale. Ferrari has introduced their first ever plug-in hybrid electric vehicle (PHEV) named the SF90 Stradale as shown in the slide. This model is quicker than the mighty LA Ferrari and is capable of driving on electricity. Ferrari SF90 Stradale also can reach 124 mph in a staggering 6.7 seconds when in attack mode. The table in the slide shows the Ferrari SF90 Stradale hybrid drivetrain specifications. The Ferrari SF90 Stradale has three electric motors under its body. Two electric motors are located in the front and power only the front wheels, while the third one, called the Motor Generator Unit Kinetic (MGUK), sits between the engine and the transmission. All three of them source the power from the small lithium-ion battery pack. With the introduction of three electric motors, Ferrari got a unique chance to create a four-wheel drive car, the first mid-engine V8 powered four-wheel drive car for the company, and utilized a unique torque vectoring system. With two electric motors in the front, the Ferrari SF90 Stradale's torque vectoring system can vary between the inside and the outside wheel in cornering based on dynamic conditions. In short, if needed, the system can apply a certain amount of power to a certain wheel in a certain moment, thus enhancing cornering performance. Therefore, apart from providing thrust and enable the SF90 Stradale to use all the available grip in the right way, the front electric motors also provide power when the SF90 needs to reverse. On the other hand, the third electric motor, called the MGUK, is an F1 derived technology that developed to recuperate energy otherwise lost during deceleration. It is an electric motor that sits between the V8 engine and the transmission. Apart from recuperating energy, this motor can also provide thrust and help the V8 to accelerate the SF90 Stradale quicker. Next, the slide will show the table of Ferrari SF90 straddle versus Ferrari LA Ferrari. Besides, the Ferrari SF90 straddle's twin-turbocharged V8 engine develops an impressive 780 horsepower and 590 pound-feet of torque. The V8 engine evolved from the one in the F8 Tributo where it developed 710 horsepower, went through a massive change. The diameter of cylinders, the bore, is increased to 88 mm. Ferrari increased the V8's capacity to 3990 cc. This is now a 4-liter V8 engine. In order to complete the changes, Ferrari engineers also modified the intake, added a new exhaust manifold, revised the cylinder heads, added new injectors, added a new smaller flywheel, and employed new engine mounts. The slide shows the Ferrari SF90 straddle versus Ferrari F8 Tributo. To fight the stresses of the all-wheel drive system, new propulsion methods, and even more extreme performance, Ferrari engineers changed their production philosophy by introducing the hollow casting instead of the rib casting. They also used new aluminium alloys, special carbon fiber, and even more rigid materials. All of this is to improve NVH values, increase torsional rigidity, and keep the weight at the lowest levels possible. In fact, the Ferrari SF90 straddle tips the scale at 3,461 pounds. Next, the Ferrari SF90 straddle has a new steering wheel and new infotainment system. With this new system introduced on the Ferrari SF90 straddle, not only the driver can control lights, indicators or modes, but now the driver also have a chance to control the central cluster screens, activate the voice control system and use the cruise control, same as on the F1 cars. The reason for the integration of even more controls on the steering wheel is because Ferrari wants to create the best human-machine interface (HMI) possible, and how better to do it than to enable the driver to control every function without taking hands from the wheel. The infotainment system and the new head-up display play a major role in this. Last but not least is the new dual-clutch 8-speed gearbox is quicker than before, 22 pounds lighter and provides a better fuel efficiency. The thing is that it does not have a reverse gear at all. If the driver wants to go in reverse in the SF90 straddle, the driver have to select E-drive mode, electric mode and select R. In that case, only the electric motors on the front wheels will provide power. That's all from me, thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aiman bin Azri. I'm from Group 5. In today's presentation, I will be presenting about the working principle of an electric vehicle drive system of a model from Ferrari or Porsche. So, let's get into it. First of all, in our presentation, I will use SF90 Stradale, which is a hybrid electric vehicle supercar produced by Ferrari to illustrate and give a better picture on how electric vehicle drive system from Ferrari works. SF90 Stradale has 4 driving modes, which is e-drive, hybrid, performance, and qualify. The first mode is e-drive mode. E-drive mode is a mode where the system of the car use only electric vehicle from the batteries to operate. This mode will be explained further in my presentation, as I will use e-drive mode as my main focus to explain about the electric vehicle drive system of Ferrari. Next is a hybrid mode. Hybrid mode is a mode which the car will decide to use the engine or the electrical motor. Basically, at low speed, the system of the car will use electrical motor, but at high speed, it will use the engine to operate. Okay, the third mode is performance mode. Performance mode is which the engine of the car will be always operating, and it will maximizing in charging the batteries of the car. Lastly, qualify mode. Qualify mode is the highest performance of the car. It will use both the electrical motor and the engine to work at very high speed, at top speed, which is 1000 horsepower. Okay, all of these modes can be manually chosen by the driver. Okay, let's focus on e-drive mode. SF90 Stradale has been installed with two electrical motors at the front axle. When the driver chooses to drive in e-drive mode, the electrical motor at the front axle will use the energy from the battery to work in front-wheel drive. In this mode, this vehicle can speed up to from 15 miles per hour to 84 miles per hour. During reverse gear, the vehicle will use only the electrical motor instead of engine to operate. The next aspect is charging. SF90 Stradale is powered by 3 lithium-ion batteries, one at rear axle and 2 at front axle. There are two ways to charge the batteries of the supercar. One, by plug-in charging. It can be charged using home charger or public charging. The second one is by regenerating braking. During braking, energy will be converted into electrical energy and stored to the batteries. Lastly, this is the schematic diagram of a hybrid electric vehicle drive system from Ferrari. Let's see. At the front axle, there are three main components to work the electric vehicle drive system. Two electrical motors has been installed at the front axle to operate with regenerative braking and batteries. The batteries will supply the electrical energy to the motor for the front axle to operate. At the rear axle, a battery and an engine has been installed. The engine will provide torque for the rear axle to operate. Okay, that's all from me. Thank you.
Let's talk about plug-in hybrid electric vehicles. These vehicles are relatively new to the roads of Canada, and they are a unique approach by automakers to respond to more stringent greenhouse gas regulations. PHEVs, as they're commonly known, also respond to consumer demands for quieter, cleaner technology when they're behind the wheel. Quite simply, a plug-in hybrid electric vehicle is essentially a regular hybrid vehicle with a larger battery pack that can be charged by plugging into the grid. The advantage of the plug-in hybrid electric vehicle is that it offers an extended all-electric range capability. Let's get under the hood. There are three main components. First, an internal combustion engine, one or more zero-emission electric motors, and a battery or series of batteries. There are a number of different types and configurations which store and send out electricity, and a transmission that transfers the motor's power to the wheels. While you are driving, a series of computers are constantly monitoring the state of charge of the vehicle's batteries. A plug-in hybrid electric vehicle is designed so that your primary power is electric, so the electric propulsion system is first in line. But when the batteries can no longer provide adequate power, the internal combustion engine is commanded to turn on and take over. For some plug-in hybrid electric vehicles, the internal combustion engine can complement the electric motor when more power is needed. The plug-in hybrid electric vehicle also has a charging coupling, a place you plug into when you are charging the vehicle. That's because the batteries in plug-in hybrid electric vehicles need to be charged in order to ensure that you get the benefit of up to 70 kilometers of electric-only range. If your battery is depleted, you don't have to worry about being stranded, since PHEVs can operate without being plugged in. Most of the time, that means charging from the electrical power grid. People who own or lease plug-in hybrid electric vehicles can charge them up at home. And as these types of vehicles become more popular, public and commercial charging stations will begin to appear that can top up these vehicles while you run your errands. It's important to note that actual driving range on electric power depends on speed driven, driving style, cargo, topography, climate control usage, and weather. But the range of the vehicle is extended since you can also operate using the internal combustion engine. Plug-in hybrid electric vehicles offer the best of a number of worlds. When running on electric-only power, they are quiet and, of course, have lower fuel costs. Their smaller, efficient internal combustion engine also helps to minimize fuel use. And plug-in hybrid electric vehicles use low-drag aerodynamic shapes, have reduced weight, and use highly advanced technology like regenerative braking, which helps to charge the batteries. So, if you are looking to cut your energy costs and reduce the amount of greenhouse gas you're producing, consider a plug-in hybrid electric vehicle.
For working calculation, the US print by Mohammed Abdul Muhammad Asmi with matrix number B041610-265. For simulation of total energy consumption of modular electric drive system. For designing the high-efficiency drive, it is necessary to know all technical parameters of platform and as well as precise description of the driving cycle of the platform. The driving dynamics of mobile platform are simulated using generally known mathematical and physical apparatus for a wheeled vehicle. This is based on the equilibrium of force, where on one side of the equation is the available traffic effort of each wheel, Ft, and on the other side is the sum of all driving resistance, Ri. After substituting the driving resistance, Ri, for the first equation, Ft equal to RRL plus Ra plus RACC plus minus Rg, where RL is rolling resistance, Ra is air resistant, RACC is resistant to acceleration, and Rg is grade resistance of the vehicle. For industrial mobile container platform, Ra and Rg can be omitted. For the second equation, the tractive effort reaching wheel Ft is expressed as the sum of the electric motor torque Me divided by the dynamic radius of the wheel Rg, where I is a gear ratio and efficiency I is overall powertrain efficiency with engaged gear. The last one equation, power. Power PE equal to Ft times V equal to Me divided by Rp times V. The power required to overcome the driving resistance of the vehicle is based on where V is vehicle speed. For simulation of driving dynamics, we use an universal environment. The parameters of mobile container platform and a virtual electric drive were entered into the environment and are shown in the cutout in figure. Thank you.
Assalamualaikum, my name is Muhammad Faisal and I'll be explaining the conclusion. Modular electric drive system is the system which is controlling the speed, torque and direction of the electric motor. The electric drive system are not the same from each other, but there are some common features consist in all electric drive systems. One of an example of electric drive system is plug-in hybrid vehicle. Plug-in hybrid vehicle is where there are both high-capacity batteries and the internal combustion engine, and the car's maximum performance can be achieved. One of the examples of plug-in hybrid vehicle is the Ferrari SF90 Solare, which is the first ever Ferrari's plug-in hybrid. The advantages is it can drive on pure electric power without burning any fuel, and the range of the driving also extended. The advantages of electric vehicle is it can boost the performance, regenerate kinetic energy more efficiently, and offer a more advanced pure electric mode of driving. This type of system is one of the best systems to achieve the maximum performance of the car. That's all from me. Thank you.